Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we are going to talk about how to find the sample sizes in order to obtain a specific level of confidence, all right? So sometimes you want to know, you want a specific level of confidence. And so whenever you plan your study, you know that confidence that you have in mind, that level of confidence that you have in mind. And so then you work backwards. You figure out what should your sample size be in order to get that level of confidence, all right? So here is the formula that is needed for estimating a population proportion, all right? The sample size to get a certain percent confidence interval for our population proportion with the margin of error E is given by, so the sample size is equal to your sample proportion times 1 minus your sample proportion times your critical value divided by your margin of error squared, all right? Now, you use this formula when you have a prior estimate of your proportion. All right, so P hat is the prior estimate of your proportion. So it's some estimate that was used in the past. Now, there is a different formula that you use if you do not have a prior estimate, and it is this formula. Your sample size is equal to 0.25 times the critical value divided by the margin of error squared. All right, so notice this formula does not have a p hat in it. So this is if you do not have a prior estimate for your sample proportion or for your population proportion. And then you always want to round these up to the next integer. And then your margin of error should always be expressed as a decimal. So let's look at two examples. One example, two different parts. So an economist wants to know if the proportion of the U.S. population who commutes to work via carpooling is on the rise. What size sample should be obtained if the economist wants an estimate within 2 percentage points of the true proportion with 90% confidence, okay? So it tells us two things. It tells us our margin of error, which is 2 percentage points. So it wants to give or take 2 percentage points, and then it gives us a 90% confidence interval, all right? So the economist uses the 2009 estimate of 10%. So this is a prior estimate of our population proportion. This was a past estimate, and that was obtained from the American Community Survey. So I have this table here. This is our critical value table because, again, it gives us our critical value for our level of confidence, and we want a 90% level of confidence. So our critical value would be 1.645. All right. So now recall that our formula, if we're using a prior estimate, our formula is given by n equal to p hat times 1 minus p hat times the critical value divided by e squared, all right? So our p hat in this case is the 0.10 from the 10%. So 0.10 is our p hat. And then our 1 minus p hat is going to be 1 minus that, which is the 0.90. So 1 minus 0.10 is 0.90. And then our critical value, which we just got from that table, our z of alpha over 2, that was the 1.645. And then our margin of error is the 2 percentage points, so that's going to be the 0.02. So we have identified each part of that formula. So now we're just going to plug it in. N is equal to p hat, which is 0.10, times 1 minus p hat, which is 0.90, times our critical value, 1.645, divided by our margin of error, 0.02, squared. All right. And that's 1.645. That's not a 9. That's a 4. Let me erase that just so you can see it. 1.645, 1.645. That's better. All right. So when you do this, you want to do the exponent first because you have to do order of operations. So do the 1.645 divided by 0.02 and then square it. Then multiply that by 0.9 and then multiply that by 0.1. And you end up getting n to equal 608.856 if I run it to 3 decimal places. But remember, it said to round it up. So in this case, your n would be 609. So that means he would need to obtain responses from 609 people from the population, okay? And this is U.S. population who commutes work to work via carpooling. So he will need 609 people to respond to his survey in order to get a 90% confidence interval with 2 percentage points. So that is how you would do it if you're using a prior estimate, all right? Now, the next example is not with using a prior estimate. So the economist does not use any prior estimates. And so in this case, you're going to use this formula. That was the second formula, which you use if there are no prior estimates. And so our critical value and our margin of error is the same because we still have the same confidence level. So 0.25, that's a 2. 0.25 times the 1.645 divided by the 0.02 squared. All right, again, do the exponent first. So do the division first, the 1.645 divided by 0.02, square that, and then multiply by 0.25. And if you multiply that out, you end up getting that to be approximately 1,691.266. And you always round that up. So your N would be 1,692. So he would have to collect responses from 1,692 people from the population. If you notice, that more than doubled. It was 609 in the last one using a prior estimate, but without a prior estimate, you have to collect more responses, which makes sense. You need a lot more responses to actually make sure you capture the true population parameter, all right? So this is how you will find the sample size if you want to obtain a specific level of confidence. And there are different formulas. One you use if you have a prior estimate and one you use if you don't have a prior estimate. If you have any questions about any of this, please don't hesitate to reach out to me and I will respond as soon as I get a chance. If not, thank you for watching and I will see you in the next video.